Hi everyone, welcome to my channel Alpha IQ. Today's topic is complex numbers introduction. Let us get into the topic. So complex numbers, what do you mean by complex numbers? The definition is the numbers which are in the form of x plus iy where x comma y belongs to R, nothing but real numbers. So numbers which are in the form of x plus iy where x comma y belongs to real numbers, where I is -1. I is nothing but iota. So generally the complex numbers are represented in the form of z is equal to x plus y, nothing but capital Z. So complex numbers are generally represented by capital Z, where x is real part and y, which is associated with iota, is an imaginary part. So imaginary part. So for example, if we take, if x is equal to 0, then the complex numbers becomes iy, which is purely imaginary complex number. So if y is equal to 0, we get z is equal to x, which is purely real complex number. So when x is equal to 0, the given complex number will become a purely imaginary complex number. When y is equal to 0, it becomes x is purely real complex number. Now let us get into some condition. The first one is I is neither 0 nor greater than 0 nor less than 0. So the I value is neither 0 nor greater than 0 nor less than 0. The second condition is, we know that square root of AB is square root A into square root B formula. So this formula is applicable in complex numbers only true if at least A or B, at least one of them, A or B, is non-negative. At least one of them should be a non-negative number. So for example, let us prove this formula. If I consider -1 into -1 is equal to square root of -1 into -1. I am applying this formula for both non-negative numbers. So according to this condition, at least A or B should be non-negative, nothing but positive. At least one of them should be positive. So if I take both negative, we are going to see whether it is applicable when both are negative numbers. So -1 is I, square root of -1 is iota. Next -1 into -1, square root 1. So this becomes I square is equal to 1, -1 is equal to 1. So -1 will never be equal to 1, positive plus 1. So according to this is contradictory condition. So this formula is applicable only when at least one of them is positive. So when both of them are negative, it is not applicable. So the formula should be written as square root of mod A into mod B into is equal to square root A into square root B. This is the actual formula that should be applicable. Now integral powers of iota. We know that I is equal to square root of -1 is equal to I square is equal to -1. So I power 4, I power 3 is equal to I square into I. I square value is -1 into I minus I power 4, I square into I square. I square value is -1, so -1 into -1 plus 1. So I power 5 is equal to I power 4 into I. What is I power 4 value? 1. 1 into I. Next, I power 6 is equal to I power 4 into I square. So I power 4 value is 1 into I square value is minus 1. So the final value is minus 1. Now I power 7 is equal to I power 4 into I power 3. So I power 4 value is 1. I cube value is minus I. So final value is minus I. So I power 8 value is I power 4 into I power 4. 1 into 1, 1. So the final value of I power 8 is 1. So now if we take some conditions, I power n. So if we take for higher powers of iota, it becomes difficult to calculate the higher power iota values. So now we take a rule, n by 4. If I divide the higher power of iota by 4 and I get the remainder as 0, then it will be I power 0, nothing but 1. So this is the short way how we calculate the higher power of iota values. So whenever the higher power of iota is given, divide the power by 4, and if we get the remainder as 0, then iota value will be the 1. So if remainder becomes 1 when divided by 4, then it becomes I power 1 is equal to I. When r is equal to 2, remainder when we get 2, then I square is equal to minus 1. Similarly, r is equal to 3, I power 3 is equal to minus I. Now next, r is equal to 4, I power 4 is equal to 1. Now let us look at some problems. 1 by I is equal to 1 by I into I by I. I am multiplying and dividing 1 by I with I. Now I by I square is equal to I by minus 1, nothing but minus I. Now I power 2, 1, 7. Now if I divide this by 4, so 1 is the remainder. So when 1 is the remainder, what will be the value of iota here? I. So the remainder is I. Now if I take higher power, it becomes difficult to calculate the value, final value. So we use the divisibility rule of 4. So what is the divisibility of rule of 4? Divide the last 2 digits by 4. 4 is 32. So the remainder is 2. So we take I square. I square value is minus 1. So minus 1 is the final result of I power 1, 2, 3, 4. Now I take I power 0, I power 10, I power 100, I power 1000 plus I power 110. So what is the value of this I power 10? For 2s are 8, remainder is 2, so minus 1. So last 2 digits are 0, so the power is 0, remainder is 0, so it will be 1 plus remainder is 0, 1. Now here last 2 digits are 10, divided by 4 we get the remainder as 2. When the remainder is 2, we get minus 1. So minus 1 gets cancelled, plus 1 and minus 1 gets cancelled, we get the final value as 0. Now if I take I power 25 minus 1 by I whole power 25 by whole power 25 is equal to I power 25 value 4, 6 are 24. So remainder is I 1. So the final value will be I. Here the same, minus 1 by I whole power 25. So 1 by I value we have already found out as minus I. So plus I whole power 25. So 2I whole power 25. 2 power 25 into I power 25. 2 power 25 into I power 25. So what is the value of I power 25? For 6 are 24. So 1 is the remainder. 2 power 25 into I. Now next problem. F I power 2 3 4 7 6 plus 1 by I power 1 8 7 6 5 4 2. So take the last two digit numbers and divide by 4. What we get here? 4 ones are 4, 3 4 nines are 36. So I power 0, because we are getting here the remainder as 0, so I power 0. Then the remainder here is 4 times of 40, so I square, so 1 minus 1, so we get 0 here. So next problem, we take 4 consecutive powers of iota I have taken here. So when you divide by 4, what we get here? I power 1 plus I square. Here the remainder is I power 3. Here the remainder is I power 4. So I minus 1 minus I plus 1. So minus I plus I gets cancelled, and minus 1 plus 1 gets cancelled. So what is the value here? 0. So this is the important result which has to be remembered. So what is the result we have derived here? Consecutive powers of iota add up to 0. So the sum of any consecutive powers of iota gives you the final value as 0. So the important result here is I power n plus I power n plus 1, I power n plus 2 plus I power n plus 3. The result is 0. So this is the most important results which has to be remembered.